Assalamualaikum and hi, it's me again, Miss Huda. Let's continue on example 5. A short reinforced concrete column is required to carry an axial load of 1,500 kilonewton. Assuming grade 30, concrete means the FCU is 30 Newton over mm square. And high tensile steel, which means Fy is 460. Design a round column containing 2% of steel. Example 5 is different from example 3 and example 4. In example 3 and 4, it requires you to get the value of axial load, which means N. Here it asks you to design, meaning that you have to find the area of column and how many bars and the size of bars that will be included in the column design. Using the same formula, which is 0.4 FCU AC plus 0.8 FY ASC. The value of N, we have it already, which is 1,500 kilonewton. However, you need to convert it into Newton ya. Sebab value yang lain-lain ni seperti the concrete grade, the steel reinforcement strength, semua dalam Newton over mm square. Equal to 0.4 times 30 Newton over mm square. This is the FCU. AC, leave it dulu sebab kita akan kena cari. Plus 0.8. FY 460. And SC tinggalkan dulu. It says here, column ni ada 2% steel. Meaning, ASC adalah 2% of area of column. But since we don't have the actual area of column, so kita akan panggil dia AG, which is this is the gross area of column. Sementara sebab kita belum lagi dapat the area of column, the actual one. Which means kalau 2%, 2 bahagi dengan 100 jadi 0.02 AG. And dalam column ada area of steel and area of concrete. Then to get area of concrete, it means that the area of column you have to minus with area of steel. Area of column we call it AG dulu. Maksud dia 1 AG ya. 100%. Okay. Jadi tolak dengan 2% area of steel tadi, which is 0.02 AG. Then 1 tolak 0.02, you akan dapat 0.98 AG. Sama juga kalau you tulis 100% AG minus 2% AG. Then you will get 98% AG, which is equal to 0.98 AG. Right now, kita dah ada ASC and AC dalam sebutan AG. Then we can replace it into the formula, which is 0.02 replace dekat ASC and 0.98 AG replace dekat AC. Solve this one and you tambah dengan this one, you will get 19.12 AG. Meaning that 1500 darab 10 kuasa 3 Newton bersamaan dengan 19.12 AG. And to get the value of AG, just simply ambil 1500 times 10 power of 3 Newton bahagi dengan 19.12, you will get 78,451.883 mm square. This is the gross area of column. Next, we can get the actual area of the column by finding the value of R. Okay, because we know that the column adalah round. which means the cross section going to be pi r square. 78,451.883 bahagikan dengan pi, then you will get this value. And you akan square rootkan value of r power of 2 itu, and you will get this value. Then you need to round it up. Here saya round up to 160. Jadi ini adalah the value of column radius, the actual one. Jadi bila you dah dapat the radius, then you can calculate the actual area of column. Use the radius yang you round up tadi. So kalau you tak round up, pakai value ini, then you akan dapat gross area of column. Tapi kalau you round up, you akan dapat the actual area of column. We know that the area of steel adalah 0.02 area of column. Tadi kita kira AG kan. Tapi sebab kita dah ada actual area of column, therefore kita akan pakai the actual one. And you will get 1,608.495. Then we can refer to the table to get the nearest value of this ASC. Tapi kena ambil yang lebih besar. 1608.495. Here, I ambil 60/20. Or, you boleh juga ambil 8T/16. Sebab asalkan value dia lebih besar daripada 1,608.495. But you have to remember, for round column, the rules is the number of bar must be more than 6 ataupun equal to 6. Okay? Tak boleh lagi rendah dari 6. So, you boleh ambil value ni atau value ni, that would be the nearest. Here, I ambil 60/20 then and the AS is 1890 mm square. So kita dah ada area of column, kita dah ada the size of the column, we also have the numbers of bar. However, kita still need to design untuk link ties ya. So untuk round column, you have a column like this and should be, if you use 6 numbers of main reinforcement, then the ties or link going to be keliling dia. Then you have few numbers of it. You're going to find what is the size of this link, berapa size dia, dan juga berapa spacing in between of this link. Using the formula for size 1/4 darab dengan diameter of the largest longitudinal bar. Since kita tak ada pakai combination of bar, kita pakai satu size saja, which is 20. So you darab 20 mm. Tapi kalau mungkin you ada combined bar, for example you pakai 16 and 12, you akan ambil value 16 ni lah to put inside this formula. Then I dapat 5 mm, and we know that the smallest size of reinforcement is 6. Tak ada yang lagi rendah ya. That's why saya round up kepada 6. And just in case if you get value, for example something like 6.25, right? So kita takkan round it down ya. Kalau you dapat the size of link ini 6.25, you kira kita akan round up dia kepada 8 sebab this is minimum value, cannot go lower than that. Then you have to take the next bigger size, which is tak ada size 7, so ada 8 mm diameter. Take 8 mm instead. Next, we're going to calculate the spacing between the bars using the formula of 12 mm times the diameter of the smallest longitudinal bar. And sebab kita punya size ada satu saja, so take 20 mm. Tapi kalau you pakai combination bar, take the smallest one which is 12 mm ya. So 12 times 20 you get 240. So you can simply take this 240 mm ataupun you boleh juga round it down sebab kat sini it says that maximum spacing tak boleh lebih daripada 240. Kalau you round down kepada 200 mm pun boleh. Because selalu kalau you tengok dekat site kan biasa dia akan pakai numbers yang memang tepat-tepat like 200 mm spacing, 150, 100, 250 like that kan. Jadi kita boleh juga round down ke 200 mm spacing. Then we can draw the cross section. The diameter going to be 320 ya, sebab radius dia 160. So 160 darab 2, 320. Then you have 6 numbers of longitudinal bar which is 60, 20. And you have the link ataupun ties which is this is mild steel R6-240 spacing center to center. Another thing yang I have to say about designing a reinforced concrete column, in this case kita design the as round column. So in your syllabus you won't be learning about the rectangular column. You hanya belajar about the square column sebab kita hanya sampai axially loaded column saja. That's why tak ada rectangular column Meaning that semua beam yang transfer to the column sama size, sama panjang, semua samalah, sama material, all four sides sama. Jadi number of bar dia untuk square column you akan pakai 4 numbers. Okay, ataupun you boleh pakai 8. Tapi usually tak adalah sampai banyak-banyak numbers kan, sebab biasanya kita nak seragam kan, so kita akan pakai the minimum kan. So 4 numbers ataupun 8 sebab dia axially loaded sebab semua sides of column tu the loading yang transfer from the beam sama. Jadi number of bar dia 4 atau 8. Depends on your design I think that will be all. Thank you so much. Bye.